Now, let's look at those excitations here. You can get them either by a real double excitation or by applying two single excitations one after another. And those T2 here, T3, T4, they are all called the connected excitations, double excitations, whereas all the other ones, like T1 squared, T1 to the third, T1 to the fourth, or T2 to the squared, they are called the disconnected. Double, triple, quadruple excitations. That's a phrase which you sort of can find in the literature. Now, there is sort of a difference between the coefficients which go in there, because here that connected double excitation has one coefficient with all the four orbital indices on it, whereas the coefficient of the disconnected double here, I mean, that's the product of two single excitation coefficients, which are determined in a different equation than those. So sort of this weight is really determined by the weight of the single excitation, and not by the double excitation itself. If one looks at a couple cluster wave function and then looks at which of those coefficients, which of those excitations, this or that, or the triples, or the quadruples, or the disconnected quadruples are the most important ones, meaning which have either individually or sort of as a sum of the coefficients, the largest coefficients, and therefore have the largest contribution to the wave function. Then we'll see if one has canonical, for canonical Hartree-Fock orbitals. You have that T1 is small. The contribution of T1 is small. Do you have an explanation for that? From what we discussed so far? Emil?
They don't connect with the ground state.
They don't connect directly with the ground state. That's one argument. One could also, sort of based on perturbation theory, Müller-Blechett perturbation theory from Tuesday, say, well, the singles only come in a second order wave function. They first contribute to the MP in fourth order to the energy, whereas the doubles, they already come in second order, and they connect directly to the Hartree-Fock. So this is large, and the singles are small. If we then look, what is the next important contribution? So this is large, and this is the overall dominant contribution. And we will see another argument a bit later why the doubles are the most important one. What do you think is the next one? Well, the next one is the triples. The triples, and this is the connected triples, meaning really that term. That's typically the next largest contribution. And then comes quadruples, but it's the 1/2 T2 squared disconnected quadruples, which is the next largest contribution, meaning not this T4 term here, but 1/2 T2 squared. And that is, that's actually very good. Or we're very lucky that it's this one which is the largest, I mean largest from the quadruples, and not the original connected quadruple. And we'll see that in a second why that is.